Hello, my name is Haziq Hamzah. I'm from Songyungwan University, and in this international conference on information networking, ICOIN2021, I will be presenting my paper called Location Aware Task Offloading for MEC-based High Mobility Service. So let's move on to the introduction. So MEC, Multi-Access Edge Computing, is a paradigm which allows us to move the cloud computing technology closer to the edge of the network. So relating to my paper, so if we have insufficient computational resources in the mobile device, we need to offload some of these tasks of the end user mobile device to the edge cloud for processing purpose. So this is what we call task offloading. So we propose a location-aware task offloading policy to reduce the service time, which I will later explain what is service time. But in summary, service time is the combination of processing time and network delay. So next, I will talk about the task offloading use case. The topology in the use case basically consists of the central cloud. We have the central cloud, and also we have the edge cloud and some of the base stations. So there are three types of network connection, which is the wide area network to connect to the internet, and also the metropolitan area network, which is the connection between the edge clouds here, and also the radio access network for the base stations. So, and also we have both vehicles, the ambulance and car, which offloads specific type of tasks. So for the ambulance, we have the e-health task, and for the car, we have the infotainment task. So when offloading process begins, we have two factors that must be taken into consideration, which is the network delay and also the cloud resources. And also we have two options to offload our tasks, which is to the central cloud or to the edge cloud. So the approach taken into solving both of these factors is called task offloading policy. So based on this, the policy is set based on the factors, options to select the cloud. That is the task offloading policy created by you. So let's move on to the proposed idea, which is my proposed policy, LATO. LATO stands for location-aware task offloading policy. The goal here is to reduce the service time. So the service time is the processing time, the processing of the task in the edge cloud or the central cloud, plus the network delay, the delay that we download or upload the task from any of the vehicles, okay? So LATO policy is different from baseline policies because it has the addition of location-aware algorithm. So we consider the location, both the vehicles and also the clouds. So without the algorithm, the baseline policies only greedily selects any edge cloud that has sufficient resources to host the tasks of the vehicles. Okay. So the mission duration here is from the source to destination. Source, the place they pick up the patient. The destination is the hospital. So that is the mission. Okay. So mission duration is how long they do the mission. So longer mission duration of the ambulance will make the number of tasks increase. So next is about the service time, which will be compared with the number of vehicles. So we take a look when the number of vehicles is at 8,000. So the average speed of ambulance is dropped to 33.55 km per hour. So just like I said now, mission duration is longer, higher number of tasks. So the more tasks generated means more cloud resources need to support the offloaded tasks. Okay, so more resources means that we need to process the task more. So this leads to a higher processing time And then if we have many tasks in the network, so it will lead to a congestion, certain network congestion, and this will be resulted in higher network delay. The service time is actually processing time plus the network delay. So that's why during the 8,000 number of vehicles, you can see that the service time is much higher. So if you can see, our LATO policy performs better because it focuses on balancing both of these factors, balancing the processing time and network delay to have a lower service time. So it is important to know the trade-offs between the processing time and network delay in order to get lower service time. So this paper is a conference version, so to speak. So it is only the preliminary results of the research. That's all about my presentation for today. Thank you. And if you have any question, please feel free to ask. Thank you again. Thank you very much.